So when we apply a value count on this category column, what will happen? We get a table like this, right? So it will show me that how many times this negative is appearing in this column, that is 54 times. And you will see that we have a nice looking frequency table. It means we are getting 63 times positive and 61 days negative, right? So now you can see that we have a scatter plot. Hello friends, welcome back to day 37 of the 100 days of hell with Python algo trading. Today we will be understanding the univariate, bivariate and multivariate analysis. So first we will understand the univariate and bivariate, and then after understanding some more concepts we will proceed to multivariate. So in previous session we understood the statistics, then we understood the types of statistics, which is descriptive and inferential, correct? Then we understood various measures of central tendency and measures of dispersion, and this video is the continuation of the previous video. Okay, so let's first understand that what is univariate analysis and what is bivariate analysis. So basically when we have a data, so in trading generally we have a tabular data, right, which includes rows and columns, or we can say a data frame. So in data frame we have various columns, right, and each column we can consider as a variable. So let me show you a table here. For example, we have this data frame which I imported from the Yahoo Finance. So I imported until volume only, OHLCV data, right? OHLCV, which I explained in the previous videos. So here you can consider each column as a single variable. Open column is a variable, high is also a variable, and you have multiple variables here, right? So when we talk about univariate analysis, that means we are analyzing any single column of this data frame, correct? And when we talk about the bivariate, means we are analyzing two columns, right? And when we talk about the multivariate, means we are analyzing more than two columns, right? That should be very clear for now, right? Okay, so let's talk about the univariate analysis. Univariate means we are analyzing a single column of a data frame, correct? So let's say I am analyzing this close column, correct? So when I fetch the data from the Yahoo Finance, I fetched up to this OHLCV, correct? Open, high, low, close and volume. Then what I did, I applied a percentage change function on this close column and I got this value, this column, right? It says means if the daily return is up from the last day, then it will be positive, otherwise it will be negative. So we got this one, and on this column I applied a lambda function to categorize that if the value is greater than 0 then it will be positive, and if the daily returns are less than 0 then it will be considered as the negative, right? Hope it's very clear until now. We will also understand this in the Python also, but for now just try to understand. Okay, so let's understand the univariate analysis, right? So in this what happens, we have two types of data, right? One is categorical and another is numerical, correct? So here by default when we import the data we do not have any categorical value because we only have OHLCV, that is numerical. So I purposely created this category column so that I can have a categorical data to show you guys. So now what will happen, I will apply a count value on this. So now what is happening, I have a categorical value which is this one, the category column, and I also have numerical, means I have multiple numerical columns, so that's fine. So on univariate we can plot a distribution table or a bar chart majorly. So what is a distribution table? So when we apply a value count on this category column, what will happen, we get a table like this, right? So it will show me that how many times this negative is appearing in this column, that is 54 times, and how many times this positive is appearing in this column, which is 51 times. And this is known as the distribution table, which we have done multiple times since childhood, right? This distribution table. And if you want, you can also create a bar chart, like you have more categories. Maybe you can say high positive, you can have, let's say, high negative, high positive, high negative, and let's say it is 40, it is 30. So then you can plot a bar chart also here, right? So let's say you have 30, you have 40, right? You have 51 and you have 54. Correct? This is x-axis and this is y-axis. And here you can label like it is negative, it is positive, it is highly negative, it is highly positive. So that means in categorical, we can draw a distribution table or a bar chart, right? So when we talk about the numerical, what we can do, we can draw a histogram. So for categorical, we can draw a distribution table or a bar chart. And for numerical, we can draw a histogram. How? Let's say we take this closed column here, and what we will do, we will divide this column into multiple bins. So let's say I want to divide this in 10 bins, and we can provide the ranges. Like let's say I want from 100 to 110, then I want from 110 to 120, and so on so forth, and let's say up to 190 to 200. So I'll be having 10 bins, and on the basis of that I can draw a histogram. Let me show you how. This is a histogram, right? You can see here, and the difference between a histogram and a bar chart is that in bar chart these bars are not attached, but in histogram these are attached, like very close. And why? Because we had the ranges, it was ending at 110 and it was starting at 110. That's why these all bars are attached. So that's the basic difference between the bar chart and the histogram. So in univariate analysis, you can have two types of data, categorical data and numerical data. In categorical data, you can have a frequency table or a bar chart, and in numerical data, you can have a histogram, right? We will understand these in the code also shortly. Okay, so let's talk about bivariate analysis. So in bivariate, we can have three types of data. We can have categorical, we can have categorical numerical, and we can also have numerical, right? So let me show you how we can analyze this. So basically what we are doing here, we are trying to find a pattern. We are trying to find a relation between two variables or two columns, right? So let's say we have this table here, and here we have this categorical column. So let's say we have this table, and in this table we have this categorical column, and we have these are the numerical columns, right? So let's try to find out the relation between these two variables. So when we have two categorical column, we can create a contingency table, right? And it shows the frequency distribution of variables, right? So we can say that when we have two categorical columns, we can create a contingency table, or we can say a crosstab, right? We will understand this in the code shortly, but for now let's understand this. Okay, then we have two numerical columns. So in that case, we can create a scatter plot, right? And scatter plot looks like this. You can see here the relationship between the two numerical columns, right? I'll explain you that how we are creating these scatter plots with the help of Python. But for now, just try to understand that which kind of plots we can create with which kind of data. That's very important, that when we have a categorical and a numerical column, so in that case, we can create a box plot. So box plot looks something like this. And to understand this, I need to make you understand few concepts, and then only you'll be able to understand this box plot. But for now, just try to remember these things, okay? That on which kind of data we are creating which kind of plot, because this will really help you in your real life scenarios. Okay, and last we have multivariate. So multivariate also will cover later, before covering few topics which are important to understand this analysis, right? So in multivariate also we create the box plot, and before that what we will cover the percentile topic, and in that I'll show you the IQR, interquartile range, and so that you will be able to understand the box plot, right? So what we'll do, first we will understand up to this scatter plot. Okay, in bivariate we will understand up to this one, then we will understand the concept, and then we will proceed with the rest of the analysis, right? So let's get started. Okay, let's try to understand the graphs in Python. So what we'll do, first of all, I have to import the data from the Yahoo Finance. So I'll write YF download, and tickers we will take as Apple, and we can start from, let's say, 2024 January to January, right? Then we can end at 24 June of 30th. Okay, so when I hit shift enter, you will see that we have OHLCV data along with the adjacent clause. So I'll just store it in the variable data. And so first of all, we discussed that in univariate, we can have two types of data. We can have categorical and we can have numerical. But here we do not have any categorical data. So for that, what we will do, we'll just try to create that. So what I'll do, on close, I apply the function percentage change, and you will see that we have another column, and we can store this in the, let's say, daily return, right? Or instead what we do, we make the category. So on any day, if the percentage return is greater than 0, then it will be positive, else it will be negative. So what I will do, I'll apply, or let's store it for now. I'll just go and store in daily returns, right? And when I check the data frame, you will see that we have another column with the daily returns. Now I need to categorize this, that on which day it was more than 0, then it will be positive, and if less than 0, then it will be negative. So I'll apply on daily returns the lambda function, apply, and here we can give lambda x will be positive if x is greater than 0, else we can say it will be negative, correct? So when I hit shift enter, you will see that we have negative and positive. So for this also, we can create another column, and let me give it the name as category of daily returns, right? And now when I check data frame, you will see that we have another column, correct? So on this column, we can apply the value counts. Let me do that, value counts, and now we have a table, right? And this is known as the frequency table. Let's make it a little bit more clear. So I'll just reset the index for this, reset index, and you will see that we have a nice looking frequency table. It means we are getting 63 times positive and 61 days negative, right? Because we import the data from January to June, means around 180 days, 6 months, and in that we have few off also, right? The weekends also. So ultimately we'll be having 124 days, and out of those 63 positive and 61 negative. So in that way you can use the frequency table, right? Now how to find the relative frequency? So for that, what you can do, you can simply, let's store it in a variable, let's say frequency, frec. Okay, and let me print it here, frec, and you will see that we have here also. Now we need to find the relative frequency of this table. So for that, what you can do, you can simply copy this code from here, and I'll just paste here for now. I'll remove this, and we are getting this, right? Here you can just give normalize equals to true, and you will get, and proportion is only the relative frequency. And if you want the cumulative frequency, the meaning of cumulative frequency is that you will add these values, right? You will combine that. So for that, you have a function, a very good function, that is sum, and when you apply that, you will get the cumulative frequency, right? And if you want, you can also draw the plots. So let's say for the frequency, which was here, so what you can do, you can just write frec dot plot, and you can give kind, and you will have a bar chart. So like if you have more categories, then it will be like good looking, and you can give the X label and Y label that we have discussed previously in the matplotlib section. And for the relative frequency, you can draw a pie chart. So let's draw that plot, and in kind you can just write pi, and it says, okay, let me remove this for now. For this, let's not reset the index, and directly plot, and kind equals to pi. I need to, okay, yeah, now you have a pie chart, and in that you can see the distribution, the positive and negative percentage. And it's very easy, like when we have multiple categories, then you can have like a good visualization, but for the less one, it is not required that much. Okay, so we have discussed the univariate. So in univariate, we have discussed the categorical, and in category, we have discussed the bar chart, the pie chart, and relative frequency, and the cumulative frequency. Now let's discuss that what we can do when we have a numerical column, right? So let's say we have this data frame. Okay, now let's discuss that we have a numerical column that is close. We will try to cut this into few pieces and let's see what happens. So I'll take the close, like this one, and let's apply a function that is pd.cut, and here I can give this column, and I can also give the bins, which I will take 10, and you will see that we have 10 bins, and when you perform the value count on this, you will have the number of bins here, and it is also a kind of frequency distribution table. So if you apply a reset index here, you will see a similar table which we have seen in the categorical column, right? So here also you can draw the bar chart and pie chart. So let's draw the bar chart. So plot kind, we can give a bar and you will see a bar chart, right? Hope it's very clear. Okay, now let's understand that we can also draw a histogram here, right? So let me do that. So for that, what I will do, I'll take again this column, right? And I'll use the function plot.hist, and here I can pass this column, and in bins I can also give 10, and when we hit shift enter, you will see that we have a histogram. So this histogram depends on that how much bins you are giving. It's completely up. If you give more, then the histogram will like not give a good results. You can see here, and if you give, it will be very like wider. Let me show you. You will see that it has bigger bars. So you need to have a balance between that. So let's try with 6. Yeah, it is a little bit okay. So it's like depends on the situation that which kind of plot you want. So this was just the demonstration, and now it's up to you that how you use your creativity and you create and you use this functionality. Correct? Okay, now let's understand that how we can plot the graphs when we are applying the bivariate analysis, right? So in bivariate, we can have categorical and categorical numerical and numerical columns, right? Or variables. So how can I create another categorical column? So for that, what I'll do, I'll create the days. So for that, data dot index, and we'll get all the dates. And here, if we use the day name, then we'll get all the days, right? And simply we can create another column. So what I'll do, I'll just write data here, and here I'll give the new column as, let's say, day name. When I check the data frame again, you will see that we have the days, that on which day we get negative or positive. So if we count the values, we can create a contingency table, a crosstab, right? So for that, what I'll do, I'll simply write pd.crosstab. This is the function. And here, first you can give this category daily returns and then day name. So I'll write category and then the second column, which is data and day name, right? And you will get a contingency table which clearly shows that on Friday you have 13 negative and 12 positive. On Monday you have 10 negative and 12 positive. So by this you can analyze that on which days you are like getting more positive returns and on which days you are getting more negative returns. Hope it's clear. It's very easy. Just you have to apply like some logic and it will become a magic for you. Okay, now let's understand that what you can do when you have both the columns as numerical. So let me show you here that we have this data frame. So here what you can do, let's find out the relationship between the volume and daily returns. So for that, what I'll do, I'll write pd.scatter, and here you can pass the volume and also the daily returns, right? And when you run this, it says it has no attribute as scatter. Okay, sir, if it doesn't have any attribute scatter, then what it does have? Of course, it will be PLT. So now you can see that we have a scatter plot, and for this actually I'll show you the deep explanation in the next session how it is plotting the theoretical and mathematical part. But for now, just understand that when we have two numerical columns, we can draw a scatter plot, right? And now the last one is that when we have a categorical and numerical. So for that, you can draw a box plot. And for box plot also, I need to show you something that is percentile and IQR concept. Then only you'll be able to understand the box plot. So, but let me draw it first. So plot and box plot. So here you have to pass a column. So column is equals to I daily return. Also you have to give here by, right? So by also you can just copy here this one and paste it here, right? Actually, box plot is applied on the data frame, so I have to write data, and then when I run, you will get this box plot. So for the understanding, we have to understand the topic, and then we will again understand this, right? Okay, let's first understand the percentile IQR, and then we'll come back to this, and we will also cover the remaining part, which is multivariate analysis, right?